Hey guys, today we are going to use proportions to solve some problems, including some real-world problems. First, a couple more properties of proportions. One, if two ratios are equal, like this, so we have a proportion, then their reciprocals are also equal. Okay, so that means that if A over B equals C over D, then it can also be written as B over A equals D over C. Okay, so you and I may write proportions for the same problem, and they may be upside down when we compare them to each other, and that is okay, as long as if I flip one side upside down, I also flip the other side upside down. Okay, another property of proportions is that elements of a proportion can be exchanged diagonally. Okay, so I can exchange the means or I can exchange the extremes. So here I'll exchange these two. So it is okay for me to write this A over B equals C over D as D over B equals C over A. So I just switched these diagonally. I could also have switched B and C diagonally instead. Okay? In this diagram, the length of AC is to the length of DF, as the length of BC is to the length of EF. Write three true proportions using the information in the diagram. So I will start with the proportion that's given. AC has a length of 12. DF is 18, BC is 9, and EF is X. Okay, so there is one true proportion, following exactly what was written here. Now, I could use the reciprocals. Okay, so I can flip this upside down. So there's one proportion. Another one is 18 over 12 equals X over 9. So I can flip both sides. Or I could exchange something diagonally. I'll switch the 12 and the X. So the 12 becomes X. So X over 18 equals 9 over, and the X becomes 12. So I just switched these two numbers diagonally. So all three of these proportions are exactly the same. Okay, so they look different, but they have the same values. They're all equally true. Now, let's just test that. So if I do the cross products, I get 12 times X equals 18 times 9. If I do cross products here, I get 12 times X equals 18 times 9. And here, if I do the cross products, I get 12 times X equals 18 times 9. As long as the cross products end up the same, then all three of these proportions are equally true. Now, find the value of X in the diagram above. So I need to actually solve one of these. Okay, so I've got 12 is to 18 as 9 is to X, and I did cross products, and I got 12x equals, now let's just evaluate 18 times 9. And that is 162. And divide by 12. And we get x is 13.5. Okay? In this diagram, JL is to LH, as JK is to KG. Okay, find the length of JH and the length of JL. So first, JL. JL is right here, and that one's actually going to be a little bit tricky to find, so let's just find the others first, and then we'll come back to JL. LH is 2. Oops, I put that in the wrong spot, so I'm going to start this over. Okay, so JL over JH, I don't know JL yet. JK is 15. And KG is 5. Now, JL. So JL goes only this far, but X goes all the way down to here. Well, I know that from here to here is 2, and all the way down from J to H is X. So right here is X except for this part that's 2. So it's X minus 2. So for JL, we're going to put X minus 2. Okay, now we'll do our cross products. And I'm going to skip a step here. I'm not going to write 5 parentheses X minus 2. I'm going to go ahead and do my distribution now. So I've got 5X minus 10 equals 30. Okay, so I will add 10, 5X equals 40, and divide by 5. So X is 8. Now we want the length of JH. Okay, so JH goes from here all the way down to here, and that length is X. And X is 8, so JH equals 8. Then we want the length of JL. JL is X minus 2, so it's 6 minus 2, so JL is, it's 8 minus 2, so JL is 6. In the diagram above, KL is to GH as JK is to GJ. Find the length of segment GH. So KL is 12. GH is unknown. JK is 15. And JG is 5 plus 15, so JG is 20. So I have 15 times GH as one cross product. The other cross product is 12 times 20, and 12 times 20 is 240. And I will divide by 15 and find that the length of segment GH is, so we've got 240 divided by 15, and that is 16. A scale drawing. A scale drawing is an enlarged or reduced drawing of an object that is proportional to the object. Okay? So a reason for a scale drawing might be that something is extremely large and we need to have it represented on paper, and it's got to be a lot smaller. Like a map. A map is not the size of the entire town that you're looking at on the map. Okay? It's much smaller so it can fit on paper. A picture of a cell is much larger than an actual cell because you can observe that picture and see the parts of a cell that you wouldn't just be able to see by trying to look at a cell. The scale is the ratio that compares the length in a drawing to the corresponding length in the object. Okay, now scale drawings and ratios apply also to models. Okay, a model is like a scale drawing except it's a three-dimensional representation. So here's like a model box car. You can have a model car. You wouldn't want your model car to be the same size as an actual car. Okay, so when we write the scale, we write the drawing or the model, in this case we're doing a model, over the real object. Okay, so in this case, a boxcar is 50 feet 9 inches long, but this model is only 7 inches long. So the scale is 7 inches over 50 feet 9 inches. Okay, now we need to make this into a ratio, which means they're going to be in the same units. So what I need to do is multiply this 50 by 12 to get that turned into inches. So 50 times 12 is 600 inches, but it's also 9 inches on top of that, so it's 609 inches. So we've got 7 inches over 609 inches. Okay? And then we can write that as a fraction and simplify it. So 7 over 609 is 1 over 87. So the scale here is 1 over 87, or it can be written as 1 to 87. The boat in this scale drawing is 3 centimeters long. So this right here is 3 centimeters long. The scale is 1 centimeter in this drawing is equal to 1.5 meters. What is the length of the actual boat? Now this is a rate. It's not in the same units, but that's okay. We can write a proportion that will help us find the length of the actual boat. And a proportion can be written in rates or ratios. So the scale is 1 to 1.5, and that's the drawing over the real thing. The drawing is 3 centimeters. How many meters is the actual boat? So our cross products, we've got 1x, and then 3 times 1.5. 3 times 1.5 is 4.5. Okay, so the real boat is 4.5 meters long. A 3D scale model of the sun sphere. This is a building in Knoxville, Tennessee. The model is 20 inches tall, and so we'll just assume right now for a moment this is the model. This is 20 inches tall, and the diameter of the dome, so across here for the model, is 5.6 inches. The actual building is 266 feet tall. What is the diameter of the actual dome? Okay, so let's go model over the real thing. So the model is 20 inches tall. The real thing is 266 feet tall. The diameter of the dome on the model, okay, so remember we have model on top, and we have the real thing on bottom. The diameter of the dome on the model is 5.6 inches. How many feet is the diameter of the actual dome? Okay, so we've got cross products of 20x and 266 times 5.6, 1489.6. And we will divide by 20 and get 74.48. So it is 74.48 feet across the actual dome. How many times as tall as the model is the actual building? Okay, so for that we need an actual ratio. So it's 5.6 inches compared to 266 feet. Now 266 feet times 12 is 3,192 inches. Okay, so to see how many times taller the model is than the actual, or the building is than the model. So I'm going to edit in a little correction here. I had put the wrong number right here. I'm comparing the height of the sun sphere to the height of the model. The model is 20 inches tall. So it's 3,192 divided by 20. And that is 159.6. So the actual building is 159.6 times as tall as the model. Last question. The distance between Charlotte and Winston-Salem on the map is about 1.6 centimeters. So here's Charlotte. Here is Winston-Salem. And that is about 1.6 centimeters. Find the actual distance between the two cities. So the scale is 1 centimeter is 75 kilometers. 1 centimeter to 75 kilometers. On the map, we're looking at a distance of 1.6 centimeters. So how many kilometers is it? 1 times x, which is just x, and 75 times 1.6 is 120. Two cities are 120 kilometers apart.